Hello, I'm Chris,
And I'm Chris.
and we're here with Simply Space to tell you how you're going to die. There are plenty of active threats to humanity. Although many of the ones we hear would most likely not spell the end for humanity, there are still many relevant threats to our well being. The first one that we're going to talk about would be the expansion of the sun until the Earth's death. Once this occurs, it would 100% be the end of all life on Earth. So, this is how it would happen. Stars are created, they live and they die. The sun is no different, and when it goes, the earth goes with it. However, there's no need to panic yet. The timescale is long, 1 billion years from now at least. If the age of the earth were compressed into a 24-hour day, humans would occupy only the last second, at most, so we still have time before that happens. So, what happens when the sun goes out? Well, first you have to understand how the sun shines. Stars begin their lives as big masses of gas, mostly hydrogen with some helium and other elements. Gas has mass, so if you put a lot of it in one place, it collapses in on itself under its own weight. That creates pressure on the interior of the protostar, which heats up the gas until it gets so hot that the electrons get stripped off the atoms and the gas becomes charged, or ionized, which is a state called plasma. The hydrogen atoms, each containing a single proton, fuse with other hydrogen atoms to become helium, which is two protons and two neutrons. The fusion releases energy in the form of light and heat, which creates outward pressure and stops the gas from collapsing any further. That helium core, though, will start to collapse in on itself, and when it does, it releases energy, though not through fusion. Instead, it just heats up because of increased pressure. That release of energy then results in more light and heat, making the sun even brighter. A 2008 study by astronomers Klaus Peter Schroeder and Robert Cannon Smith estimated that the sun will get so large that its outermost surface layers will reach about 108 million miles out, absorbing Mercury, Venus, and Earth. This would be called a red giant, and when this happens, the sun will be considered in the red giant phase. Even Mars won't last as a habitable planet. Once the sun becomes a giant, the habitable zone will move out to between 49 and 70 astronomical units. The place to live would be Pluto and the other dwarf planets, comets, and ice rich asteroids in the Kuiper Belt. The next way our world is likely to end is a supervolcano. Supervolcano describes a geological phenomenon never witnessed by man. Supervolcanoes are off the charts big when comparing them to a normal volcanic eruption. Supervolcanoes don't look like a typical cone shaped mountainous peak. Instead, supervolcanoes have what are called calderas. A caldera is a vast sunken area that is formed after previous super eruptions when the ground was blown out and fell back to rest. By geological convention, a supervolcano is one that produces an explosive eruption of more than 450 cubic kilometers of magma, which is approximately 500 times more than the Philippines' Mount Pinatubo in 1991. Locations that remain active today include Toba, the Yellowstone hotspot in the northwestern United States, the Long Valley caldera in eastern California, the Taupo volcanic zone in New Zealand, and several spots in the Andes. Instances of volcanic eruptions are at their highest in 300 years, and scientists fear a major one that could kill millions and devastate the planet. On May 18, 1980, Mount St. Helens in the northwest corner of the United States erupted. It killed 57 people and expelled 1 cubic kilometer of ash. The first Yellowstone supervolcanic eruption, 2.1 million years ago, was at least 25,000 times larger than the Mount St. Helens eruption. Two other Yellowstone eruptions, 1.3 million and 640,000 years ago, though smaller than the first one, would still dwarf any normal volcanic eruption. There are some estimates that 87,000 people would die immediately. Most far reaching of all, however, would be the effects on global climate, which would resemble those of a large asteroid impact. Sulfate aerosols injected into the stratosphere by a super eruption could drop temperatures over much of the Earth by 5 degrees to 10 degrees Celsius for up to a decade, devastating global agriculture.
The next active threat to humanity is a global pandemic or biological warfare. Biological weapons are infectious agents that have the capacity to debilitate humans in the most severe way. Bacteria, fungi, and viruses fall into the category for perfect definition of a biological weapon. Hosts of these very harmful and toxic microorganisms can also be considered weapons for bioterrorism. Gram for gram, biological weapons are the deadliest weapons ever produced. Germs' capability of being spread globally so easily are what makes them so lethal. Biological weapons haven't been vastly used since World War II, but they still pose a great threat to humanity. The unpredictability of them is what worries scientists. Specifically engineered pathogens contain massive killing potential because of their ability to be easily spread, the difficulty to detect them, quick kill times, high kill rates, and more. For example, a country or terrorist group might contaminate food and water supply or use insects, expose individuals or aerosols to spread a pathogen. Recently, diseases like Ebola have proven highly infectious, lethal, and a challenge to contemporary medicine.
One of the most well-known large-scale threats to the world is global warming. Global warming is the term used to describe a gradual increase in the average temperature of the Earth's atmosphere and its oceans, a change that is believed to be permanently changing the Earth's climate. The phenomenon of sea level rise resulting from thermal expansion, seawater expands as it warms, and melting ice sheets in Greenland and Antarctica is the perfect illustration of climate inertia in action. The shocking truth is that climate change has only just begun. Regardless of future emission trends, the CO2 footprint from our brief passage on Earth is going to remain in the climate system and impact the well being of all terrestrial life for what could almost be considered an eternity. The majority of CO2 emitted from burning a single ton of coal or oil today will be absorbed over a few centuries by the oceans and vegetation. The remaining 25% will still be affecting the climate in 1,000 years. Once humans turn up the planetary thermostat by 2 degrees Celsius, the goal to which the international community is committed at present, albeit very optimistically, there will be no turning it back, save a trend towards planet-altering geoengineering. Instead, the temperature control will be locked in and all life forms on Earth will be pressured to adapt for thousands of years. The climate change-driven ecological destruction that we are witnessing today, a measurable loss of human life, plant, and animal species caused by natural disasters such as floods, droughts, and wildfires and heat waves, the disappearance of vast snow caps, glaciers, and almost half the Arctic is a result of a mere zero point 0.8 degrees Celsius rise in the average temperature since 1800. We can only imagine what a further 1.2 degrees Celsius rise before 2100 will mean for the Earth's already vulnerable ecosystems and at climate risk communities. The methane trapped inside Arctic shelves may be released with the melting of the ice caps, which could be an apocalyptic level event. Some scientists believe that the mass release of methane caused the Permian extinction. In a paper published in the Paleo World Journal, the team said, based on measurements of gases trapped in calcite, the release of methane is deemed the ultimate source and cause for the dramatic life-changing global warming observed at the end of Permian. The heat death of the universe is the next massive threat to humanity that we will discuss. The heat death of the universe is a possible ultimate fate of the universe in which the universe has diminished to a state of no free thermodynamic energy, and therefore can no longer sustain processes that involve that increase entropy. As the universe continues to expand, less and less energy is available to use. If the topology of the universe is open or flat, or if dark energy is a positive cosmological constant, both of which are supported by current data, the universe will continue expanding forever and a heat death is expected to occur, with the universe cooling to approach equilibrium at very low temperature after a very long time period. The theory of the heat death of the universe comes from William Thomson, who proposed the idea in the 1850s. The next massive threat to humanity we will discuss is the crossing of the Earth into the galactic plane. Approximately every 33 million years, the Earth's path through the Milky Way galaxy crosses through the galactic plane. The galactic plane is the area in the galaxy where there is an increased concentration of dark matter. As a result, gravity is stronger in this region. Space rocks are much more likely to hit the Earth when it crosses into the galactic plane. Nearly every mass extinction event in Earth's history lines up with the Earth's crossing into the galactic plane. The next time the Earth will cross into the galactic plane is in approximately 30 million years.